welcome to Hot Stacks, and thank you for coming. Yeah, there we go. Lots of love. Yes. So for those of you who don't know, this is sponsored by Algolia and StackShare. For those of you who don't know what Algolia does, we're a hosted search API, and we plan to bring beautiful, relevant search to the masses. And I'm Alex. I'm our developer event manager. And I'll let Jonas take it away before getting the panelists up here.
All right. I'm with StackShare, and we help developers figure out how to piece together their tech stack, StackShare.io. And we do have a little bit of data science going on very soon in terms of recommendations for your stack. So I'm super excited to learn about how to bootstrap your data science stack and how to then do it at scale. So welcome to all the panelists. I guess we'll do formal introductions soon. Let's go. I'll let everyone introduce themselves, actually.
I'm Ladan. I'm a software engineer at Segment. Segment's a company that helps understand your users, so we're a data platform and help pipe that data into different marketing tools as well as a warehouse.
I'm Ankit. I'm the co-founder and CTO at Postman. You guys use Postman? Okay. I love this response.
All right.
So we founded Postman back in 2012 and started a company formed in 2015. We are based out of Market Street right now. Yeah. Yeah. Let me see. Can you hear me now?
Oh, there we go. Perfect.
And I've been involved with APIs for the last 6 years. I've been working with Postman for the last 4. For the first 3 years, I was pretty much doing some analytics work for Postman inside, because when we started the company, I was just telling her before that we had 650,000 users before we had a company, so that was really fun. So it was a very interesting position to be in and just investigate how people are using Postman around the world. I mean, Postman came about in Bangalore, in India, and I think by the end of the first year, we had about 50,000 users spread out the world. You'd expect US, but we had people in Nigeria and China and all over. That was really cool.
Hi, so I'm Michelle. I'm an engineer at Google. I haven't been there for very long. I focus on the Google Cloud Platform, which is what I was using at a startup. I was previously head of data science at a startup named Cordoba. So I'll probably be talking a lot about that. That's probably a little bit more relevant to you than my experience at Google. And yeah, so I focus on big data and machine learning, mostly with tools on GCP.
I'm Juliet Hougland, and I'm a data platform engineer at Stitch Fix. Stitch Fix helps you find clothing that you will love to wear. We have a men's line, a men's line, a women's line, plus sizes, maternity. And we have about 80 data scientists. And so being on the platform team for a large group of data scientists that have a lot of diverse use cases ends up being a pretty interesting engineering challenge. So hopefully I have some things to share about my experience at Stitch Fix. I've only been there for 4 months, so I feel pretty new and fresh. My experience in the past was working at Cloudera as a data scientist, and so originally pretty engineering-heavy data scientist, and then a more internal analysis-focused one. And so in my past, I've switched back and forth between doing data science and then doing engineering, building tools for data scientists. So hopefully that'll be an interesting background.
All right. So quick check here. How many data scientists do we have in the building, in the room? Raise your hand high. Okay. All right. So a good number of folks that are not data scientists. So who wants to take the all-important question of what is data science?
A job title that gets a mathematician that knows how to program paid more.
Okay. Is this true, data scientist? Okay. All right. Well, I mean, data science, I was joking because I was reading a Stitch Fix blog post before this about data science at Stitch Fix, and it's basically a glossary of every term you could think of related to data science, and they do all of it. So I guess it would be helpful to understand, before we dive into the tooling and all that, what role does data science play at your company, and now versus where do you see it going, right? And maybe we can start with Stitch Fix and how you guys use data science.
Sure. So data science has been important to Stitch Fix from the beginning. We buy inventory, we buy clothing, we mail it to people, and we pay shipping costs on that. And so discipline in all areas of our business and executing really well has been important to the success and profitability of the company. In order to do that, we've applied data science in a variety of places. We do it for forecasting forecasting how much people will buy from us, what items we should buy, how much of them we should buy, what items we should recommend to people. And we don't actually have a pure recommendation engine that just sort of sends the top 5 items to people. We have stylists that use an application that we've built internally, and they choose a custom, like this is what this person needs and wants. So we have a human computation aspect, which is what information do we put in front of humans to get them to use it. So much more. We make our own clothing. We style it, we make sure the fit is right. We do a lot of customizing of the fit and figure out what clients we're not serving well. And so every part of the business we have slowly grown into and try to integrate with.
So it's safe to say it's pretty core to what you do.
Absolutely. And from the beginning, we have had Eric Coulson, well, close to from the beginning. He's early on been involved in Stitch Fix and has been a top-level executive that has been a powerful force in making sure data science gets all the infrastructure and needs that it requires. And Katrina, the CEO, has always been very interested in using data well and having a very disciplined business that executes well.
And it's so central to what you do. You have a CAO. Tell them what that means.
Chief Algorithms Officer. So, yeah, so that's Eric Coulson. He used to run data science at Netflix and started advising Stitch Fix early on. And eventually he became so interested in the company and really enjoyed the culture working there that he came over to run algorithms, or algorithms and analytics as the department is called.
Awesome. So, I mean, what's interesting about this panel, I think, is that for Stitch Fix, it's core to what you do because ultimately it drives sales, right? And then, so I think you're the only one here that can really say that. Everyone else, I think, is going to talk a bit about how it informs the product offering, probably, right? But for you all, it's a revenue driver, right?
Yeah, it's a core part of the product, absolutely. Like we make sure that when an item gets to you, it will fit you, for example, or hopefully it fits you. And if not, we're very good about sending you a new size.
Yeah, I mean, I'm going to start off by saying that I think there's a lot of overlap in engineering and data science. And back to the question of what is data science, it very much depends from company to company and from department to department. So I'll say that I have had so many titles over the years, and I'm the same person. They were basically the same-ish job, even though they really ran the gamut from app dev to data engineer to just plain developer to data scientist and now back to engineer. I feel the role at Google, obviously, data scientists are very important because that's how we serve our customers. We have a lot of data science customers. But at my previous role, where I was head of data science, I worked very, very hard to make sure that there were not big boundaries between data science and engineering. And it happened to work really well because I had joined an early stage startup. It was pre-Series A. I was the first employee, the first hire in San Francisco. And so I had a lot of freedom to really integrate closely with the engineering team. So the role of data science there was very non-specialized. My role was to build NLP products on the platform, but that role very quickly turned into building that out in Kubernetes and then moving the entire rest of the platform onto Kubernetes, which is definitely more of a DevOps role. I mean, I remember people asking me, are you our new DevOps person? But I think that was one of the most successful projects I've ever been involved with because there wasn't a strict boundary between data science and engineering. And we all reported to the CTO. We were a fairly small team. We didn't have these very strict data science, data engineer titles. And I think that was really integral to our success. So my answer to what role does data science play at your company, I think all of us have the power to shape what that means, and because it differs so much between companies, use that to your advantage. I had a very good experience by not segregating that too much.
So we look at data science as a combination of business intelligence and predictive analytics to some extent. So where data science plays a role in our organization is both on the business side and the product side. On the business side, we look, so Postman also...
Hey, Ankit, if you...
Or maybe even try switching.
Oh, can you give me
Perfect.
if I were a rock star. Right, so from the business side, Postman has a SaaS offering that is used by developers in teams to build out their APIs collaboratively. So that offering is on a traditional SaaS model. So we use data science to predict churn across our existing teams who are using the product. We use it to predict conversion of free users across clusters around organizations. Postman is used around I think 250,000 organizations around the world. So it's always good to just study how people are using the product. And at the same time, we also look at how people are using it in trial offering that we have. On the product side, the things get a lot more interesting because Postman has always been anchored to this term of REST client, which is around just making an API request. But we actually do a lot more things that we do in the product, including mocking and monitoring APIs and all of that. And we started looking at data science as a way to introduce different features to our users instead of it being splash screens and more traditional way of introducing features which are a lot more inclusive. So we look at patterns of how people reach a particular point in their workflow of using Postman and how they got introduced to a more advanced feature. And we leverage that into building user experiences and also pinpointing product features at the right time to our users to introduce features which are really when there's a need for the user to actually use something like that. And that is really cool. And so we also have this product called the Run Postman button, which is usually used by companies to publish their APIs, and about 350,000 such buttons exist. So we have quite a few APIs that are invariably hosted on our platform. And some of the things that we are looking at doing with data science is also ensuring delivery and discoverability of APIs, which has been a problem ever since APIs exist, through our platform, which are structured, which are also curated, and again, give you a problem to a solution that you may be looking at that particular point in time. And that's a role that is, it's not there yet, but that's something that we're building towards.
From the vendor's perspective, so Segment kind of helps with understanding who your user is, what they're doing, and where they're doing it within the context of your application or web page. So while we provide that for users, we actually dog food our products, and two really cool things that we do is we have these cloud sources, so we pull in data from different tools that we're using internally, two of which are Stripe and Zendesk. So for example, we use Stripe for all of our business revenue, so all transactions live in Stripe, so we pull that information in, and that's how we calculate our total ARR. Another one is Zendesk, so we track all customer touch points and how we're interacting with those customers, and all the metrics that we pull in help us determine customer satisfaction and also build out SLAs and see, given this customer, what kind of SLA can we provide them in future contracts. So those are just two cool ways that we dog food Segment and understand the users better for building out that touch point interaction.
All right, so now that we know a little bit about the why and the what data science is and the role it plays, can you talk a little bit about your respective tech stacks, your data science stack? And that can be from, anything from, what we started on. That would be helpful to understand for the folks that are thinking about spinning up a data science team or a data science capability. So maybe where you started, right? Your sort of beginning stack, and then where it's evolved to now.
So I've been at Stitch Fix for 4 months. I'm going to talk about where Stitch Fix is now. Stitch Fix has always been very, very heavily an AWS shop. So our data warehouse is made out of files living on S3. There were 9 core tables originally, and I'm not sure about the other infrastructure that existed over the last 7 years. So
Redshift.
There was a Redshift, yes, we have, but we've been trying to slowly disentangle ourselves from Redshift. But a lot of not particularly huge files on AWS. So the way the data platform works at Stitch Fix is that we try to enable data scientists as much as possible, and we don't build ETL for data scientists. We think data scientists should be responsible for their own ETL and making sure those things function. Because of that, we do things like help containerized execution. We have an open source project called Flotilla that was released in the last month, which allows data scientists to say what Docker image they want to use, put in some parameters that they may need to have available in their jobs, and integrates with our scheduling systems for when these things will run, or there can be just a submit button that when there is capacity on the cluster that executes these containerized jobs, it will run and then keeps track of the state. We also have infrastructure for helping data scientists deploy services. This is something that the team that I'm on works on, which is how do we easily provide a framework for people to define an API that engineering can call? So how do we serve recommendations to the stylist app? Well, we can have data scientists building their own Flask apps. That's a possibility. Or we can try to wrap that and make that as simple as possible, make monitoring of that simple as possible. And so it's a lot of tools around model building and containerized execution in particular, maintaining a data warehouse and metadata on the data warehouse, making that available to data scientists, and helping data scientists produce services or dashboards, whatever it is they need to communicate with the business.
So what would you say are sort of some of the building blocks of the entire data science stack? We've got AWS where everything's being hosted. Are there core libraries that you feel like are core to the whole stack?
So I think library-wise, that is what I would think of as what data scientists themselves use. And we have such a diverse set of problems that there's some people that are trying and comparing different optimization libraries because they're working in our operations department and they need to do routing through the warehouse or whatever it is that they do. And there's some people working on recommendations and they're heavy users of mixed effects models, and so they need to use libraries in R, but they'd love to get away from that, and they're experimenting with models in scikit-learn and trying to figure out how to do that. So I don't think there's any library that's core. Data scientists themselves, like, we're heavy on experimentation and trying new things and trying out different libraries. On the platform side, we use ECS a lot, Elastic Container Service. We help data scientists make Docker images and the dependencies that are inside of those Docker images, make that easy to make. So
Okay.
I'd say containerization is pretty core. Handing a microphone to Michelle.
All right.
I have a lot to say about containerization. So I guess I'll kind of start with some historical background. The reason I'm at Google right now is because I spent a lot of time on the Google Cloud Platform at my previous company. And the cool thing about joining a startup so early is that you don't have any legacy things to maintain. And so I don't know if anyone's compared the AWS console to the GCP console, but so I was.
They're not here to defend themselves, so.
I'm telling a story of my own personal experiences.
Please proceed.
So I was coming from a different startup that was all AWS based, and when I got to this new company, they were also previously on AWS, and they had very recently switched to GCP. And they were doing a lot of roll your own open source products on just cloud VMs, which was a really easy swap over from AWS. So I had a lot of freedom to, okay, there's this pretty much greenfield environment, and I can compare the tools that I was using before to these new ones and essentially go back to AWS if I felt it was justified. But it was actually a really delightful experience working with the GCP console, so much so that I quickly fell in love and used a lot of managed services. So the way I got onto Kubernetes from a just roll your own open source environment was I was working on an NLP product, basically a classifier, and my requirement was just to have a REST service that the rest of the platform could call. And I had Dockerized that and tried to deploy it on the existing Mesos platform, and basically got shut down by, like, you want how many resources for training? Our entire platform runs on a quarter of that. You can't have it. And so since all I needed was a REST interface, GCP has this really nice managed Kubernetes environment. So I already had things Dockerized. I could very easily and very quickly stand up a cluster and get that up and running. So after they sort of denied me being able to release my app on Mesos, like 24 hours later, I sort of handed them a REST endpoint and said, here you go, add this to the back end. And they were kind of shocked by that. And so it turns out that Kubernetes was a really, really good fit for the rest of the platform. It solved a lot of issues that we were facing platform-wide. And so for us, it was a very natural, okay, we need to forklift everything from like roll your own into this managed environment. And so we ended up, by the time I left the company, which was late, like end of 2017, we were running everything, like all production code within this Dockerized Kubernetes environment, running things on GCS, so that's the S3 equivalent, and backend, all the storage was in GCP as well. And it was a really good, smooth experience. The other part of the stack that I really liked and that helped in that Kubernetes deployment process was something called Weave Flux, which is another startup. They're based here as well. They have some people in London and some here, I think, in the dog patch. But that helped us get a really nice, smooth CI/CD process. And that was actually really key to solving a lot of those issues that we encountered just rolling our own. Because what that helped us do was basically anytime I, as a data scientist, would merge some code, we would have a Jenkins service that would build that container automatically, shove it into the Google's container registry, and then we would monitor that, pick it up, notice that we had a newer version that wasn't running on our cluster, and deploy it for us automatically. And so to see stuff go into production, all we had to do was merge a PR, and that really transformed the development process. It made things a lot more efficient from a development perspective, and it was a lot easier to version. Everything sort of lived in GitHub instead of being in all of these config files sort of spread out. So for us, like the move to Kubernetes was central, and it was like both a managed Kubernetes service that did that, and as well as using like a few third-party tools like Weave, and I think we had a Jenkins server running as well.
All right.
Okay, so we started with the ELK stack, Elasticsearch, Logstash, Grafana, and then Grafana for operational metrics and Google Analytics for most of our application metrics. Over time, that stack started failing a lot because we would hit some Elasticsearch limits. We needed to have like at least like 2 developers managing Elasticsearch scripts to get pretty much any meaningful information out of the stack. So then I started investing into like what is the next step that we need to take. Data warehousing just made a lot of sense, and the simple principle that all data that exists is generated either through product metrics or is generated across any other third-party service wherever we are interacting with the users needs to be decided inside a single data warehouse. So then we decided on Redshift, and for a BI platform we went with Microsoft Power BI, which I think was a really interesting way to go about it. Initially, Power BI did not have a connector for Redshift, so we had to also host our data and mirror it across to Azure SQL data warehouse. But then finally, when Power BI got a native connector for Redshift, I think we just moved stuff there. On the analytics side, we use pandas on Lambda functions. We use a lot of Python around here, usually either on Lambda functions or on EC2 instances. We started using SageMaker recently for machine learning, so I'm still like getting my hand around that because that's pretty much the process that we're establishing within the company. And one more thing that I think I've liked a lot on AWS is Glue. We were like pretty much like we wrote our own ETL pipeline inside AWS using Lambda functions, but then AWS Glue is something that I've started liking a lot for just orchestrating and frameworking like a lot of things. We have a pretty small data team, like we have only 2 people, so we got to a fairly self-sustaining platform which allowed us to do all of our BI needs and at the same time also do data science on that basic blocks that we have built out on the system.
So as a vendor, I actually don't work on necessarily building out this stack, but I have heard from a lot of customers and how at a smaller scale, maybe you don't have like a data science team fully built out and you don't have the resources to maybe build this out yourselves, watching people scale with different tools. So seeing how some of our segment customers have taken those first steps to getting to where all these other companies have gone, and seeing how, okay, we want to leverage tool A, and this is great, and now we're small, but now we see our customer pool grow significantly, and they have the ability to scale and say, okay, well now I'm going to use tool B that scales with our growth. And eventually getting to the point of now we're going to send data into a data warehouse, build out this team. And it's really cool to see too because you can grow and scale with this tool is able to understand my users and I can take action on that. But how do you get to a point where you need actual custom event tracking and understanding of those users and be able to optimize on the system and build out eventually machine learning and having this holistic view of the customer and seeing how personally, like Segment has helped those users scale. And internally as well, we are finding that we've used a lot of this this concept of how do we get a holistic view of our customers and leverage different tools to take action and understand those customers better. And that's done via this new product we call Personas. So we can have this view of the customer, say, okay, for example, Facebook lead ads is quite expensive, but let's make sure that we're actually sending the right kind of customers those specific ads and actually returning on investment that money that we're spending out there. So it's just really cool to see as a vendor.
Yeah, so speaking of vendors, I guess this is just for the vendors, but can you talk a little bit about what you've seen from customers, similar to what Segment's seeing? Can you talk about just some of the interesting tooling you've seen around data science and anything that surprised you?
I can probably speak to this. So we've been growing quite significantly. We have these larger organizations that we're supporting now, and within these large organizations, they have a lot of business units. And one challenge we were approached with one customer was they had internal tracking, but each business unit was tracking things their own way. So we helped come in and we were like, okay, let's take a step back here and understand what is it you're trying to achieve, what are you trying to track with your users and understand. And from there, defining really standard schemas for what data they're collecting. And then from there, they could, as an organization, say, okay, each business unit should follow this standardization. And then from there, they could use their own stacks within each business unit through Segment. But it still had this really unified view. So eventually, when they do turn on this tool, such as Personas, they can actually leverage that holistic view of the user because their data is trusted. I think that was the biggest challenge for them is they couldn't really trust the data because there was no unison across the entire organization. And then from there, I think with machine learning and user prediction, that's going to be completely useless unless you have that really high quality data and holistic view of the user.
Anyone else? Yep.
I mean, I think what I've seen by far more often than anything else is people just using standard compute nodes and just forklifting what they've been running on-prem into the cloud, or just sort of starting out at a VM level and managing their own machines. And that has a lot of overhead associated with it. And while that is a very easy way to forklift, you're just sort of losing out on all of the managed services. Like for me, that was the big game changer is when I stopped using my own VMs and stopped having to worry about packages and versions not being consistent and trying to do my own things. To just using the managed services. So there's definitely a push from our side to like, hey, there are all these really nice things. Like I think our Hadoop, our managed Hadoop is literally vanilla big top, and you can customize it in whatever way you need. But just sort of leveraging those services, I would say, is the direction that people are moving, and I've seen a lot of success in that stage.
Okay, so quick hypothetical question for the panel. Let's say there was a company that was 10 people and helped you see tech stacks behind all the different companies, right? And now they want to go ahead and start recommending tech stacks, and they have a Rails stack. What would your recommendation be on, let's say there's going to be 2 engineers working on this, right? What would your recommendation be in terms of how they should go about building out their data science stack?
Buy your own servers and manage them.
Okay, that's one way to go. That's one way to kill the company.
Yeah, that's the last thing I think anyone is going to do in this day and age. Cloud services are absolutely where it's at. I certainly think that there's a really good cloud service out there that's really easy to use. Get your data warehouse in order and start designing a reasonable core schema for the tables and core information that you have. And then be mindful about data scientists documenting their work as they go along. Something as simple as a Google Doc where they're, like a lab notebook, where they're writing what they've found and discovered about the data along the way, and are iteratively making that data better, because your original schema is going to have some weird ETL bug that you find, and you're going to need to go back and fix it. And being able to track those things over time ends up being pretty important. And then beyond that, starting simple and trying to use cloud services when needed, and deciding when you need to build your own things. But for your first recommendation system, Start really simple. Think of it as just one big ETL pipeline. You're going to publish something at the end, and then figure out how you want to publish it.
So AWS. Okay.
I do not endorse that recommendation. I mean, managed services is the secret sauce. I think I've made that abundantly clear. But I would say, like, spend time up front defining the problem correctly and then use the right tool for the job. Not everything is a hammer. That will very quickly either derail you or give you a lot of success early on. So I don't know, like, that's a really hard task to sort of automatically recommend a stack, just because are they at the point where they've defined the problem? Like, that's, I think, more important almost, because technology is really just a tool. The business problem is more important. There are people behind everything that you're doing, and so the stack is kind of secondary. Just make sure you have the problem nailed down first.
I completely agree, and I think it's really easy to also go hammer in terms of expenses, because when you're starting out, like we were, like, I remember getting on calls with BI vendors, and then effectively, I think at the end of the day, at our user base, we were looking at a bill of $20,000 a month, just looking at base ETL plus BI on top of that. And it gets really expensive really fast. That's why we decided to stick to data warehouse, build that core competence around data within the company, and invest in the right spaces when, like, the opportunity presented itself. And I mean, I loved Segment when I checked it out. I loved a few of the tools, one local here was useful. The things that I loved about them is what I adopted into our own stack, the ideas. But the tooling itself, just like, I could see that becoming really expensive. And as you very clearly said, that it's extremely important to nail down a business problem first, to be in a position where you can actually get actionable data which powers your business and your product. And once you reach that particular stage, it makes sense to start looking a little bit more into more advanced aspects of data science.
Yeah, I guess don't build out your own tools if you don't have to. I think there's a really good ecosystem out there of different tools that you can leverage. And if those don't, try them out. If they don't work out, go down the task of building out your own. But and also don't dynamically track events. I think that's one thing I saw a lot of customers starting out, not sure what they wanted to track, dynamically just sending all these different events, and that's not going to be fun to try to query and understand later. So yeah, just I think taking a step back, understanding, okay, what are we really trying to get out of this, and getting that business case locked down. And I think that does change as you grow, and just kind of revisiting it over time, because I think I was trying to understand the other day what percentage of all Segment users are sending data from an iOS source, and I couldn't do that. And I think it's interesting because that seems very obvious now, but taking a step back and understanding, okay, well, now that we've grown and we're kind of trying to get to that granular data, re-implementing things and updating things as we go along as well. That's going to happen.
All right. Questions?
I have two questions. One for everybody, sort of, and then one very selfish for me. Number one is like for sort of knowledge transfer with the companies. It's like how systems work and how they evolve. How do you keep track of that? Like, what tools have you find to be useful along that?
So the question was knowledge transfer within the organization. How do you do that, right? How do you make sure that everyone within the company understands what's happening as far as tooling?
It's like where the data lives, what queries to run, how to run those queries, what the dashboards, all that.
Okay. Oh, I think the answer is no one knows.
I mean, I'll take a stab at like how we approach this. So we do document like pretty much everything we do on Confluence, and just try to enforce that as part of the onboarding of every new employee in the system. This is where actually some vendors actually have a very significant advantage. Like if you use a tool like Looker, you get this layer called LookerML in between of your data, and then that's a lot easier to explain because you're looking at models rather than looking at data sources, and that's pretty much like the only view that we have. But I think for us, we instituted the processes primarily through Confluence documents, and just trying to enforce that as a people process rather than a technology process.
We use mode as well, and you can like star and have predefined queries for the entire organization to use. And I'm sure other different tools also have that ability. And we also, as a company, do analytics office hours. So if somebody has a question weekly, our team is available to help answer that. So those are just two ways that we do that.
So we use Mode as well, but for Mode, I think his question is more about how do you even know to use Mode for certain things?
That's a great question. I usually just ask people.
Okay.
Yeah.
Segment.ai. All right.
So a company as large as Stitch Fix, particularly in the data science analytics function, it becomes really challenging to have continuity on teams when people change, or even communication across teams. And I think that that is a reality absolutely everywhere. I used to work at Cloudera, and I would go to Cloudera customers, to really big Cloudera customers who had sophisticated data science functions, and talk to them about their problems. And this is repeatedly a problem everywhere. And so there's some amount of process/culture, which is what I would describe, okay, you should do this documentation, or something that Stitch Fix is investing in on the platform team is onboarding, which I think is a really, really good idea. Where you bring people in, they don't know your company yet, you tell them how it's done. You're like, around here, we have these certain standards, and it may be aspirational, but even bringing people in and telling them that this is the culture that we have, and having some people bought into that, it actually begins to spread. And so I think there's documentation and process. Tools that I've seen do this really well, and I really like, is that Alpine Data Labs had a tool called Alpine Chorus, where it was a recommendation engine for tables that you might want to use, or models that are similar, features that people have used between different models. And I think that that's a very clever idea. A similar idea is a tool called Elation. Elation has data lineage built in. Something that we have in particular is this guy named Kurt. And so Kurt, everyone should have a Kurt. Kurt specializes in institutional memory and collaboration. And so a lot of what,
Oh, okay.
useful.
So, interesting. So what tools does he use?
He builds his own. So the first thing is that what we've done is do things like tagging pieces of our infrastructure. So let's say you have, so Flotilla is our containerized execution helper. You can tag Flotilla jobs, you can tag services that you could deploy, and these get tagged with names and unique IDs and associated with teams. And so currently we're building basically like Facebook for data infrastructure at Stitch Fix. So you get a page, you log into it, and I think they're going to be rolling this out really soon, which I'm excited about, as you get this role of like, awesome. Here are the jobs that ran, here are the jobs that failed, here are the PagerDuty alerts for the services that your team is responsible for.
Newsfeed.
Yeah, and I think one thing is missing is this unified view, because so many data platforms, like no one really wants to buy a whole data platform, and various platforms have this very isolated view, but data science and the process of it is a convoluted mess for everyone. Right? Like it just rolls into every piece.
All right. Was there a second part?
And then sort of the soft question. Speaking of onboarding, I just joined a small startup on a contract basis helping fix onboarding. It's focused on front-end engineers, but I'm curious, from a data science perspective, how do you measure comprehension? How do you measure understanding? How do you measure flows? It's like a person comes to the homepage of a developer-focused product. How do you measure that they understood it? Like, what are the tools that you found useful to, what are the things you fixed to help people use your tool? Like, it's a pretty tricky problem.
I mean, I guess you can always keep track of, like, identify what metrics you care about. Like, what metrics would represent understanding to you? Would that be page visits? Would that be number of containers created, number of PRs merged? But first define what that list would look like, and then you can track that somewhere. We have a lot of tools for dashboarding. You can always look at that. I mean, I would say, back to your previous question, because I didn't really chime in, but I think the most important thing is to empower people to do that I think that was a very, very common statement, that when you need something done, how do you know where to go? You ask someone. I have recently been overwhelmed with a large amount of incoming information and needing to find that. the thing that Google does really well is empower their engineers to find information. That's been a really big change for me, and I would say whatever tools you choose, just kind of stop that bottlenecking of people time, because that has a people cost, that has a like psychological barrier of being dependent on someone else instead of being empowered to do it yourself. And also, even it could be super low tech. It could be like we literally have a Google Doc called like the magic carpet bag of everything you need to know as a Noogler. That's fine too. But that's a place where you could track all those metrics of, okay, what are our data scientists doing with their time? What kind of tools are they using? And are they using the ones that we expect them to be using? But like literally creating charts and just looking at metrics that you think represent that.
All right. Other questions? Okay. Well, I guess I would think that it's useful to come back to this question of how you should go about building this in the first place, right? Because it sounds like we have a good mix of, we've got an 80-person data science team, God knows how many you all have, and then and then I guess you're just spinning up the data science team, or there's no data science team per se?
We have one. I think just generally like some customers we find don't have that, and so we do offer solutions of scaling a business that eventually will have one.
Okay, but it's not like 80 people.
Probably like 10. I don't know how many people are on our data science team.
Okay, so I guess it's interesting just to hear that the variability here and the different team sizes. So what are some, we didn't actually touch on one of the questions, but what are some of the biggest challenges you've seen with trying to build out that data stack or even get it into your product, right? What are some of the biggest challenges you've seen, and maybe some lessons learned and words of advice to other folks that are trying to do similar things?
So we were prepped with questions beforehand, and when I saw this one, I was like, I don't know, I've been there for 4 months. I can speak from what I saw at Cloudera with the other customers, but I thought it was interesting which itself was interesting times. And first, I would say if you're going to build a data science team, actually empower them to make decisions and integrate with the business. Don't just make them a reporting team. Otherwise, it's very easy to build a reasonable schema, put a BI tool on top of it, and let other people get data out of it. Don't hire a PhD to do that. It's a waste of money. It's a waste of time. They'll quit within a year, or maybe a year and a day. What I've seen at Stitch Fix, more specifically, I asked people on the data platform who had been there longer than me what challenges they had seen, and one person who joined around the same time pointed out that I could look at the tools that we've built, and that points out the technical challenges that we try to deal with. So there's containerization and managing environments and scheduling workflows. But I actually think the technical part is not the hard part of what challenges you have in building out a data platform. And that was reaffirmed by other answers that I got to that question. So the guy that works on the compute infrastructure pointed out he keeps the Spark cluster running. When he needs to change the Spark cluster version, it takes a lot of coordination because that is at the bottom of a stack, and there are a lot of independent pieces that interact with it and depend on certain behavior. And so data choices, you seem like, oh, you can just change it at any moment, it's fine. You can switch out this thing for that thing. There's actually a lot of gravity with data, and it will stay in a format that you put it in for a long time. And so getting experienced people and getting advice on it before you put it somewhere is wise, because I think it's hard to change that out. The thing that really stuck with me is Kurt. Everyone should get a Kurt. Kurt said that the biggest issue from early on was understanding that we don't, as engineers, when we're building out a platform, we don't have the perfect stack in mind. We don't know exactly the right thing to build. And so engineers tend to invest a lot of emotions in the things that they make, I think. And when that happens, they're not willing to burn it down and build a new thing that's better. And so treating the platform as an experiment, so despite what I say about there being a lot of gravity, you also have to understand that there might be a lot of work to change it, but that doesn't mean it's not worth changing it. And so being able to treat your infrastructure as an experiment is extremely powerful and useful. And then another person, Stefan, pointed out that it's really useful to be able to get out of people's way as you continue to make progress. So don't be a blocker as a platform. Don't lock down your system so much that data scientists can't do things. Trust other people that you work with enough for them to have capability to do the things that they need to do. Don't become a blocker in that. And I think that all of those pieces of advice are coming from different experiences people had and working in different parts of the platform, but all of them are very sound.
All right.
I think I have 2 quick points. Number one is one of the big challenges I've seen is just kind of reinventing the wheel. So don't skimp on training. So if you are building something from scratch, make sure that your engineers know what they're doing. Make sure that they have gone to workshops, that they have good people to go to ask for advice. Make sure that they have what they need, because that will save you so much time in the long run. But then the second point to that is that if you don't need to build it from scratch, don't. Find the shortest path to solve the problem that you're looking to solve, and go from there. That requires less training, but the more you can just use something, the more you can use the wheels that other people have invented, the better.
I think for us, apart from cost, one thing that we had to fight against was for this function to become this reporting function, that where somebody is just asking the data science team to build out dashboards. And the way that we went about it is that to make consider this as a platform and make it as self-serve as possible, where there is constant training of other functions within the team on how to use the data platform to build out their own metrics and their own dashboards, because you have a lot more context on what you want to measure, rather than somebody who's called a data scientist but literally is a business analyst. Right? And that's something that I've fought back on quite a bit. And I think that has helped a lot, because divisions within our company, marketing, customer success, are a lot more enabled now on the platform to get their own data needs sorted out. So data science has a more holistic view of all the data that exists inside data warehouse, and to get actual insights which will help the function in the long run, rather than being just reporting everything.
I think definitely also just investing the upfront time and getting all stakeholders from every team involved in what you're defining, what you're trying to understand, and that standardization, and obviously that will change and grow, but having the initial conversation with all stakeholders, because everybody within that company can optimize within their teams, like he's saying, and I think that's just really an important conversation prior to even building anything yet, is really understanding what you're trying to achieve. It's really important.
Okay. Any last questions? You got some more? All right.
One of the what are your favorite little simple things that had a really big value as far as bringing either more internal developers on board, or for Juliet, or for you as external developers? What are the little things that made the comprehension of the product much better?
Documentation in the form of tutorials. I think data scientists are technically competent, and if they have a tutorial that walks them through the pieces that they need to understand very clearly, that gets it adopted incredibly quickly. People will just use it. That's a high value thing that I think a lot of developers just skimp on.
Any other quick wins? Easy wins? Okay. Low-hanging fruits, yes. Okay. All right. Well, I think that concludes the panel. Thank you, everyone. We'll see you at the next Hot Stacks. Thank you.